So, yes, I work for Sigpos in Dresden. My name is Jiří Kraml, and welcome to this talk. Quickly, what we're going to do today, I'll tell you how signed keys work in SSH, why we use that, why I think it's a good idea, and why you should use it too, and how you can do that. We'll demonstrate that shortly on the... Yeah, that's not supposed to do that. We'll demonstrate it on the command line. It's really easy. So, let's get started. So, what my company does is we have an indoor localization system, and as part of which we have a small Linux appliance that we ship to our customers. Those customers are mostly in the manufacturing industry, and they're very worried about industrial espionage and stuff like that, so they really don't like anybody connecting to stuff in their factory or any data leaving that factory. So essentially that means we have no way of remotely administering most of those appliances. And well, you know how it is. Sooner or later you need to troubleshoot something, or ideally you go there to expand or reconfigure the system. But anyway, sooner or later somebody from our company needs to actually travel to that factory and log in on those devices. And for us, that's a bit of a problem. Obviously, we could just deliver devices without any password at all, but obviously that it's not best practice. We shouldn't do that. So we need some kind of access credentials. But now we have a problem because the life cycle of those devices, from initial delivery to our customer to its eventual replacement or upgrade, it doesn't really match the life cycle of our team members, because that's a number of years, like say 5 or 10. People are constantly joining the team, or they're leaving. Some people join and leave, students, for example. And now we essentially have two scenarios which are relevant to us. If somebody new comes, I need to give them access to those devices so that eventually they can go there and do stuff. And if they leave, I'd like to be able to promise to our client that there is nobody out there who has any access credentials to to the hardware that runs in their factory. And as we'll see, it's not quite trivial to solve that, usually because of this no remote administration constraint. So what does SSH offer? What we could use? The simplest method is passwords. Everybody knows that. I mean, my grandma knows that. Then you have key files. You probably do know key files. Is there anyone, who uses key files for SSH? About half, but you all know that, right? It's like on GitHub, GitLab, you can do your Git commits via SSH. That's how I suppose most people get to know these files. Then what I'd like to talk about today is key files with an additional certificate. And then here only shown in gray, just for completeness, there are so-called pluggable authentication modules where you can arbitrarily configure that Linux login process. You have those little TOTP tokens with the 6-digit time-based codes. That's usually implemented via that. But that's out of scope for today. I'm not going to talk about that because that's a very large subject. So let's have a look at the password. Now we usually, on that appliance, there's only one service account, imaginatively named Sigpos, like the company. And with one account comes one password. That's the way it is. So if I have multiple people going to the client, doing stuff, they all need to know that password. Usually they save it in some, they have a password manager or something where they save that so that they have access to it, because in some of those factories you can't even phone home or anything. You need to go there prepared. And so they all have the same password, which I suppose there's a lot of companies who do it that way. The onboarding process is very simple. Somebody new joins, so we just give her the password. She can go there, do her work. That's fine. But what if somebody leaves? Then we'd have to change that password. But now we can't really, because we have no access to that device. So there would be somebody out there who potentially has that password. Not that I think they'd do anything evil with it, but you know, again, I'd like to make that promise to our clients. So, and also even if we could change the password, because we do have access to some of those appliances, still you need to tell all your colleagues that you changed it because, well, you know, it would never work. You know, you'd go on vacation, come back, they change the password, they don't tell you, you go to the client and you look stupid because you can't log in. So that's, you know, that wouldn't be the way to go. What SSH offers then are SSH keys, you know, public-private key pairs. And they have a major advantage already over passwords in that you can have multiple keys per account. There is this, I suppose you know that, there is this authorized key file where you put on each line all the public keys that are authorized to log in on that, on that account. So that's a major improvement, because now me and my colleagues, and you know, we can all have different key pairs. So if somebody leaves, you know, we can just disable that one single key, and that's it. The other people are not impacted. Likewise, if somebody new joins, we just add another key, and that's it. You know, again, for us, that constraint, we can't do that remotely, so that doesn't really work. Also because even here it's even worse, because we couldn't even provide onboarding, because if that appliance is already at the client's factory, there is no way for us to, like, you know, get a new public key on that device. You know, we could potentially like provision 30 spare keys or something, but you know, that's not the way to go, because then the administrator would have the private key, and we don't want that either. And you know, even for people leaving the team, those keys are basically valid forever. There is no, you know, like with passwords, you can at least set an expiration date. I think that's a default feature. Or with those keys, you can't. So, you know, this solution doesn't really tick all our boxes. Well, so, you know, what do we do now? It turns out that there is a very good way of doing this, and that's what I wanted to show you today. It's signed SSH keys. It turns out that it's possible to issue certificates for the public keys, which confirm that a given public key is valid for a login on a certain machine. So from the point of view of the user, it's not much of a difference. You just have your normal public-private key files, and in addition to that, you get a certificate file. You needn't even be concerned about what's in there. You just have it on your disk, and that's it. Basically, it works out of the box for you as the client. And from the server point of view, the difference now is we don't have an authorized key file anymore. We only have a signature public key, or like there's a signature key pair, and the public part of it, we put that on the server so that the server is able to verify their certificates. And the server now only needs to trust that public key. It doesn't need to know beforehand which clients will be connecting or not. So how that works is essentially you type SSH user at host on your command line, and your client tells the server, look here, listen, I've got this public-private key pair, and I know you don't know if you can trust it, but I also have this certificate. It sends that over, the server verifies that using the key, and then it knows that the public key is trustworthy, and from then on you just continue as if you had a completely normal key pair without any certificates. So a certificate contains a number of claims. It's assigned to a specific public key. It's assigned to a specific username. And what's important to us, it also contains a validity, like a time frame during which it is valid. And that now is, that does the trick for people leaving the team. I can just issue those certificates for a very, very short time period, in minutes, theoretically, but practically what we do is, you go to the client on Monday, you stay for 3 days, so I'll issue you a certificate valid for those 3 days, or maybe 4, just to be on the safe side. And you go there, you do your work, and if you leave, the certificate expires and it essentially becomes worthless. So, and then I can, with a clean conscience, claim towards our client that there is no person who has any kind of access to those devices running in their factory. likewise, if, for the onboarding process, if a new colleague decides that they also would like to, drive for long hours and then sleep in hotels and then, work in a factory, then they'll just generate a key pair. I will sign it, or the administrator will sign it. They get the certificate, and they're ready to go. There's no interaction with the appliance whatsoever from our side. And that's what we wanted. That's the constraint we have to live with. And that now works. And speaking of the validity time, which does the trick for expiry, if you think about it now, your system clock accuracy becomes part of it's a security concern now, suddenly. So you need to make sure those devices have a valid, the clock runs correctly, at least on like day granularity or something. Because otherwise, if I could somehow, make the server believe it's last month, I could just acquire an old certificate and log in with an expired certificate, which, kind of defeats the idea that expired certificates are worthless. But actually that whole thing, it's not news at all, because you already have that problem. Because I suppose most of you do some kind of traffic over TLS, like, you type in google.com, and that's got a certificate as well, with time with a certain expiration date. Normally, that's not an issue, because if you install your Linux, then, normally it's at least I think for all major distributions, it's just configured to fetch time from the network, and your clock is never that much out of date. The only place where I've ever had that happen is a Raspberry Pi, because who owns a Raspberry Pi? Yeah, and it doesn't have an internal clock now, does it? So, yeah, you can buy one, that's true. It's not even expensive, but, I had that Raspberry Pi, disconnected it, put it on the shelf for a year, then I took it out again because I had some free time, and for some reason it didn't fetch the network time, I don't know why. So it should just, the clock never advanced. If the clock was 1 year out of date, I wanted to open Google, and it said, Google has an expired certificate. And it's like, what, Google? And yeah, it turned out it was just my local clock. But, okay, to get back to the presentation. This whole thing here, kind of unfortunately, is an open SSH feature. You may be aware that there are multiple SSH implementations. Open SSH is, as far as I know, by far the widely most used one. I don't know if there is a Linux distribution that has a different implementation. I don't think so. So when you have Linux, as you probably all do, when you have SSH, that's what you have, basically. The Mac users, I don't know where they get their SSH from, but I think they have that too. At least my colleagues do. And, if you have colleagues who still use Windows, yeah, they might be in for an unpleasant surprise, because all their fancy desktop applications like PuTTY and WinSCP Mobile Xterm, they don't support that, unfortunately. I mean, there's a couple of workarounds. Come ask me if that's an issue for you afterwards. But, mostly it should be fine. Even Windows users with this, Windows 10 Linux subsystem, that's basically a Ubuntu on the, it's a magic Ubuntu that spawns in your computer. That has OpenSSH as well, so they can use that. It doesn't have a fancy window, but, they got to get used to it, I guess. So, that's basically how that works. And we'll just show that real quick on the command line now, so that you see that it's, there's no magic involved. It's actually quite simple. And I have prepared this is like a completely normal virtual machine in VirtualBox. It runs a completely normal Ubuntu freshly installed 19.4. No customization whatsoever. I just installed that yesterday. So here on the left side, I have a terminal in which I'll be executing some commands. On the top, you'll see the files which are in this current folder, And on the bottom, that's the log output of the SSH daemon on that virtual machine. And we will now generate a key pair, sign it, configure the server, and log in. So first of all, let's generate a key pair then. SSH keygen that's the tool you use for all of this. Yeah, we'll just give it some kind of name, my key. We'll not use a passphrase for the demo, although I would encourage you to use one. There we go. We see here we have generated the key pair. That's the private key, the public key, just a key as you know it, no magic whatsoever. Now we'd like to sign it, so we need a signing key. This might be the point to mention that for OpenSSH, to keep it simple, for this whole signing process, they also use completely normal SSH keys. They do not use those X509 certificate stuff that you use for TLS, for your web server. They only use plain SSH keys, which keeps things simple, but does have the disadvantage of, for example, you can't daisy chain signatures. If you open your browser, go to, say, Google.com, you'll see that domain, it isn't signed by one of the root CAs, but instead the root CAs, they sign with their root certificate, they sign an intermediate certificate, and that then signs Google.com, which has the advantage of, that root certificate, you need to keep it very, very secure, because you don't want anyone to get access to it. And then you sign those intermediate certificates, which aren't that critical because they also aren't valid for so long, a couple of weeks, I guess. So you rotate these, but you keep the root certificate fixed. Now this would be convenient, but unfortunately we can't do that. We can only have a single layer of signing for SSH. So there will be one signing key, and that's the key you sign those key pairs with. So I encourage you to give that a very good passphrase. We'll just generate one now. And yeah, usually you think about bit lengths here and if you use elliptic curves or not, but this is a demo, so we're not going to overdo it. Again, a passphrase for this key, you really should use one, but I'll skip that too. And yeah, I skipped I forgot to enter file name. We'll call that CA key. And skip the passphrase for the demo. And now we have another key pair. Public key, private key, just as you know it, no magic. Now we use that to sign. We use SSH keygen again. It's good. If you read the man page, it can do all kinds of magic. You can even do revocation lists for these certificates we are again going to generate now. So, but let's sign it first. It's -S for sign, then we enter the key we use for signing. That's the CA key. We need to give a certificate an identity. That's going to be logged on the server, and you can also revoke certificates by that ID. We usually use something like Johnny's key or Peter's key or something that's very easy to see. Let's just call it LinuxDays, and you can give certificates a serial number, which is also useful for revocation. Just use 1 or whatever. It doesn't really matter. It's arbitrary. It's just for you to have a way of keeping keeping tabs on which certificates you issued. So let's use that. And now we need to enter a so-called principal. Usually, unless you do fancy stuff, the principal is simply the username you want to log in as. On my virtual machine, that's Zigpos, like the company I work for. And you can do fancy setups where this kind of works like access control lists or like group memberships. You don't have to. Normally, it's just the username. And then lastly, we just enter the public key we want to sign, which is mykey.pub. And there we go. It says signed this key, blah, blah, ID, valid forever, because I did not specify a validity. I could have done that. I purposely skipped that for the demo. And now you see we have a new file, mykey-cert.pub. That's the standard naming scheme. If you stick with that naming scheme, it's all very comfortable. It's like the base name of the key, .pub is the public part, and -cert.pub is the certificate. If you absolutely insist on renaming that, you can configure your SSH client to use a differently named file, but just stick to the standard. Doesn't hurt, and you don't have to configure anything. That's way more comfortable. And let's have a look at that certificate first. Again, SSH keygen does the magic. It's capital L for, I don't know, list, probably. F for file, and we want to see my key -cert.pub. And you see here that it has a type. As far as I know, that's actually the only type that exists right now for this. It has the fingerprint of the key the certificate belongs to, because we can't just gamble on the file being named the same. So this fingerprint is the fingerprint of this public key. It has the fingerprint of the signing key, which is associated with this one. It has a key ID, which we entered. It has a serial, which we entered. It's valid forever, and the principals are interesting. That's the user we are gonna log in as. So now we'd like to use it, but our server, it's a fresh install. It doesn't know anything about this. So what we do is we configure it now. We will first copy the CA, the public key. We only want to copy the public key. The private key should never, leave whatever you consider secure, like your company probably. We'll copy that to the virtual machine. Yeah, we have to use the password now because it does not yet accept any certificates. There you go. You see here on the right there is some logging output that we had a short session, and now we log in to configure that server. Again, yeah, we move the key to some, normal location. I consider it a part of configuration, so I move it to /etc. Your view on that might differ. It doesn't really matter. And then we edit the configuration. SSHD config, and it really is only a single line, which we'll append to the end. It says trusted user CA keys, plural, because in theory you can have multiple authorities if you like. And it's located at /etc/SSH pub. So that's it. We only have to reload the SSH daemon. There we go. We log out. And now we log in. We need to tell SSH that we'd like to use our key. We're not going to specify a certificate or anything because, again, it has this default naming scheme. I say I want this key, so SSH uses this public part and this certificate automatically because it has the same name. And there we go. That's it. It's as easy as that. There is no, it's quite a simple tool, but it can become very useful. And so, yeah, that was that. That was the demo. And say now you're convinced you want to use that. It needn't even be that you have appliances with no remote capability. It's also useful for, if you have a server farm of a couple hundred servers, you can use that as well because you don't want to be copying all those public keys everywhere. So you can use this as well. Also, if anybody of you knows HashiCorp Vault, it's a secret. It's like a server for keeping secrets, like passwords and stuff. It can also issue temporary SSH logins, and these certificates is exactly how it does that. So let's say you wanted to use it now. So how do you go about that? You saw it's quite simple, but as IT people, we are lazy, so we don't want all that hassle for more than a couple of people. So as a responsible IT person, what do? Well, you Google the problem. And you'll see that there are actually a couple projects already which will help you administer all kinds of certificates. But upon reading the README, you'll notice that they're quite large in scale. They're meant for teams of 100 or more people. So yeah, maybe that's not, at least for our company, it wasn't right. There's only 20 of us, so we don't want to be running an extra web server for some kind of front end. We don't want any additional administration whatsoever. So I'll show you how we do it. It's publicly available on GitLab. You're welcome to fork it. I'll show you the link at the end. What we have is we have a simple repository in Git because we have a GitLab instance anyway, so it's no additional infrastructure for us. It contains a single script that handles the daily business, namely signing new certificates. And we just then put all the certificates into that Git repository, so we'll always know who has what certificates, which of them are valid or not. Here on the right side, you see a screenshot from my file manager, and it's really simple. There's just a key folder with the CA key, the signing script, and a folder where we put the certificates. Yeah, it's really all there is to it. We, I believe, still have time, so I'll just show you that real quick. We'll just check that out. After I've got the tab open, if that loads. Yeah, it does. We'll copy it, clone it via SSH. By the way, if you run your private GitLab instance, you can also configure SSH, like signed SSH keys to use for that. We didn't, but you could do that. We'll git clone it. Yeah. Now, normally you'd read the README, but because I wrote it, I know what it says. So we'll just go to keys, remove the key that's present, generate a new root key, CA key, no passphrase. Actually, I'll use a passphrase for the demo at this point, because that's how we do it, right? Because it's in a Git repository, anybody can access it, so we need a way to keep the private key inaccessible, which basically is just a passphrase, which internally works by the SSH client encrypting that file, and we keep the very, very long passphrase just in a key pass, or the admin does it. So we did that. Here we are. We have this sign user key script. So we'll generate a key. We could sign SSH key again. I'll just call it my key again. Yeah. And now, well, I can't remember the arguments. So it's the pub key to sign. That's my key. The key ID is LinuxDays something. That's the passphrase for the CA key, and that's it. Really, it signed the key. It moved the copy of that certificate to this certificates folder, and here you see it. We have this CA key. We have this new certificate, which we just signed. And now we'd git commit and push, and the colleagues would pull their key, and that's it, really. You're welcome to fork that. So now, the credits for the icons, I didn't draw them myself, and I suppose we were a bit quick on the time. More time for questions. Thank you for your attention, and I'll take your questions now if you have any. Yes? What about using Let's Encrypt for the CA? For your use, no, unfortunately it's not, because OpenSSH uses a different kind of certificate that Let's Encrypt does. It would be cool if we could do that, but unfortunately, you have to have your own CA infrastructure. Also, then I'm not sure if you'd want that strictly to somebody else to sign your keys, but depends on your use case, obviously. Yes? Excuse me? How will we remove the certificates was the question. Well, we don't. We can't. So the trick is to make the expiration very short, so that Yes. Like you could, but we don't because we don't have that remote access. You can generate key revocation lists. That's possible. So if, say, you had like a server, like a lot of servers, and you'd like to use that, like for internal development, for example, we don't have like short-lived keys. They're generated every month, and there it would be a problem, but internally we just, reconfigure the servers. You could also, if you like, you can configure your SSH daemon to execute an arbitrary command to get a key revocation list. So you can just curl for it from an S3 bucket, for example. So you could do that. Yes? Excuse me? Well, if we all have access to the passphrase, no, of course not. Yes, exactly. Then it would be pointless. Only I and our administrator have the passphrase. And yes, then we'd need to, you can just change the passphrase, that's sufficient. So they don't need to actually have new keys. What some people do, if you read up on it on the internet, some people do it that they have multiple CAs. In fact, in case one gets compromised or something, then they have fallback keys which are already signed, which they can switch to. So yeah, that's for our case where we do it like this. You need to keep that passphrase secure. But you can also, I've never tried it, but it should be possible to use a YubiKey for signing, where you have like a physical token that's able to sign those keys. I haven't tried that yet. I think I might for next year. Yeah, maybe. Any other questions? Yes, please. The question was whether we could use X509 certificates. No, unfortunately, that's the same case as Let's Encrypt. So, like, not with that. It would be, as I mentioned, those PEM modules. You can, customize whatever you like. There might be a way to do that, but I suppose it would be a lot of trouble to do that. Anyone else? No? Well, then thank you for your attention, and I guess the talk is over.